This is iteration number 2 of this print, a spool holder for the Sovol SV08. If you look at my other prints, this is the previous one I did, and see how easy it is. I'm looking from the front now. I can see how much filament is on the spool just by looking over. So some spools are more like this, and on the original spool holder it holds them this way, so that you can't really see the amount of filament on that spool. But once they're on the spool holder that I've designed here, you could look over and see how much filament is on the spool. A lot less number of supports here than in the previous build. The previous build had a lot of ribs. I basically removed them, redesigned the filament run out detection bracket, 3 supports, 35% infill. You have to be careful when you need this printer because it moves that quick. See that there? If you're used to other printers, it might be you say, what's that ring there at the back? That's like a manual feeding mechanism. But see how fast it's turning here. And that is because inside this head it has gear reduction to give more torque to any filament you're wanting to push out. Just a second, sorry. I'm hoping to get some of the noise of the fan sorted out on this. So that's the display that comes with the printer. You can upgrade it because the USB is LAN port and even a HDMI port, which I think, upgraded screen will probably use those ports. A textured build plate here, magnetic. I don't need to remove this magnetic sheet normally. Once it sticks on like glue, honestly that is stuck on there really solid, no problems. Just trying to show you there's no carving here. There's a bit of a curve in the print on that edge. But even that's not caring. Really, okay. Textured build plate. Once it cools down, I can just lift the part off. On a big print like this, well, the previous iteration I did, which I just showed you, is connected up here now. The main problem here is this filament detection unit is a bit not ideally placed. On this it should be better, and there was an awful lot of support on this one. Can I show you? Because of all these ribs here, tree supports. I mean, there was some tiny ones in there. This spool is like a bayonet fitting, like an old light bulb. This rolls round the mound on a couple of skateboard bearings on the inside. I'm going to straighten that out, I think. Don't really like it like that. But anyway, once the bed cools down, I can just take, well, the smaller pins. It's just like picking up something like this, you just go. With the bigger pins here, I had to pull a little bit, but not major. Right, just wanted to show you the tree supports mainly, I think. Trying to get it from this angle. But we have to be careful here. You see, there's a lot less tree supports. That might use a bit more plastic, but 35% infill here. It has to be pretty strong. It's got to bear up the weight of 1 kilogram at least. Or if you have a bigger spoon, it should manage it. Noise levels on this machine is a bit ridiculous. Why don't printer manufacturers, put quite a fan on them, even if the bigger fans for the control board, the bigger fan generally has to turn, well, slower, a bigger diameter fan doesn't need to turn too quick, and that reduces the noise levels dramatically. Now, people talk about fitting Nokia fans to these. My understanding of Nokia is to reduce the speed. That reduces CFM, like the airflow. I think it's measured in CFM, cubic meters per meter or whatever it is of air. You reduce that right down, reduce the speed down, that gets the noise levels down. But if it didn't pump out the air that you need to keep things cool, especially when working this quick, but it could cause issues. Anyway, I'll probably come back when this is finished. I'll test out the filament run out thing on it to make sure that fits better. So as I know, this is not full speed, this is standard setting pretty much. I think I did increase retractions and, well, I removed the page line, that Sovol, the one here, that's in the start G code in the Orca slicer, that page line, which to me just wastes filament. You can do a skate round, that's why I do, that gets any filament blown. Probably don't use so much filament. Okay, I'm going to leave this part off here and I'll show you when it's finished. Well, there we are, finished. You see tree supports, but a lot less tree supports than the previous model I've done. The previous one had these bits in which had an awful lot of sometimes really small tree supports in. So basically I've just filled all that in. And she's still on the bed's still a bit warm. The tree support there. That supports this overhang here. So this is the first iteration. Basically this is pretty much the same. Got no ribs in this one. There is a sort of curved indent in there. And I'm hoping that this peg type thing here, which is supported by these trees, well, it has to be supported by something because it's sticking out in the way. That's for the filament run out. Because where this in is, it's not ideal. Can I get a bit better light on that? This works okay. But it's mainly filament run out, I think. That has anyway been improved on this one. I'm still waiting for the bed to cool down before I even attempt trying to take it. Oh, that's on there. That's on there. I am pulling, twisting it a bit. That's on there solid at the moment. The bed's on 48. I don't know. Take my word for it. When it gets down to 30, I'll have to try again. Obviously, I could lift up this build plate sheet and flex it a bit to get it off. I don't really like doing things like that because I believe it's just a sort of belief there's a chemical composition on the surface, and if you do try and take it off too early, it could damage our chemical composition, even a tiny bit, but over time it's going to lose like the forces that keep it on bed. That's just a theory, okay, there's probably no truth in that. Right, the bed's at 38, still on there firm. Just leave it a bit longer, let the bed cool down a bit more. Right, I've left it quite some time, quite a few hours. The bed's on 29. Let's try it now. Yeah, see the difference there? And I was tugging quite firmly earlier on. That's the texture. I only use cheap budget, let's call it that, if you like, PLA. Let's look at this side. Right, and see, if you look at the previous video where I had like cross braces in here, there was a ton of these tree supports. Some of them were absolutely minute and took quite a bit of mucking about to get them removed. So this is the filament detection sort of thing here. Let's see. See, the tree support is quite big. Oops. There's some of the tree support on there. Let's look at this. Trying to scrape it a bit with mine here. So pretty good there. A little bit of a mark, I think. Oh, this is a problematic part, because this is like a curved edge that's on the bed. Let's try to do these one very low down tree supports. This is a functional part anyway, so that's going to need a bit of work, I think, maybe a file or something. Let's try and get this off here. Have to be careful here, because there is like a bump like this. That's what the beam is. Try fitting that is on the spool. Let's try and get the point off. This part seems quite a bit difficult difficult to get removed. See, I have to be careful not to grab the bin itself. Boom, let's call that. Sorry, going on the camera here, but I'm to hold it. So I'm only getting little bits off. That is problematic. Odd, the other ones came off pretty easy, as you've seen. I'm going to probably have to go off camera, sorry. I'm going to be pulling off these small parts. So on this edge here, I'm going to put a screwdriver and tap it, okay? Flat bladed screwdriver. You should have to be very careful of this peg thing. So that seems a bit better. I managed to get this screwdriver just in the edge. I was going at an angle like this, trying to avoid this peg. Tapped it about 3 times slightly with the edge of these plies, and can see there's a small gap opening up there. I tried to get this. I can't really. Well, a screwdriver. I'll leave it. Trying the same on this side. Well, this one seemed more difficult. So I was trying a bit smaller blade. I was coming in like this and twisting it. And as you see, it's coming off at least partly. It's going to be, I'm going to continue on with this one, trying to dig about at it. Well, I managed to dig it off with that small screwdriver, sometimes tapping it with the edge of the long nose pliers gently, well, or I would say firmly twisting and just digging at it gradually. You see the marks on it. I don't know why that part up there was almost welded on. So that is a peg thing is wanted, because on the spool it is a bayonet fitting. Right, I'll get this fitted. See how on here put a bit of a chamfer. I'll probably do the same on the inside anyway. All that's to strengthen this corner coming around here, like an elbow, trying to give you a good look around. I'm not asking for ironing or anything. That's a very good quality. This is for the filament run out detection device. The screw on here. I'm not asking for any ironing or anything like that on the top surface. Okay. I've used input shaping on here. There's a slightly bit of like an echo there, very slight if it is. Get this on. Well, these are all M4s. I put it on a bit loose with a washer on so it can move a little bit if it needs to, as filament is going in and out. I'll fasten this bolt and shoe back up just now and show you. So a washer and then an anti-vibration washer on there. Yeah, that just pushes in and turn it a bit. This easily rolls. Couple of skate bearings inside there. So that didn't impact that sort of tree support. That was a bit of a nuisance. So there it is. Wooden tube here fitted in. Clip on. And as I said, that's got a bit of movement if it needs. That's okay. Spool on there. So now, now I can easily see how much filament is on the spool. Okay, there's the front. Just look over and say I'm getting low.